So here's your next example on concavity, and this one has to deal with a trig function. So the process is the same, and this one, as usual, the trig function, we have a limited domain. It's from 0 to 2 pi, so we're going to consider that. But first, let's find the possible points of inflection, which is where the second derivative is 0. This derivative should be easy. I'm not going to refer to it from alpha. The first derivative is just x plus 2 cosine of x. And then the second derivative is 1 plus 2 times the negative sine of x, so minus 2 sine of x. To find the possible points of inflection, we're going to find out where that equals 0. So we're going to bring the 1 to the other side, cancel out the negatives. So we have 2 sine of x equals 1. Sine of x equals 1/2. That's a nice number for trig because that can be found in the unit circle. Sine is y. So we're on the y-axis. We need to find out where sine is 1/2. So that's the short length up on the y-axis right there. That would indicate this spoke and this spoke. This is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and this is 5 pi over 6. So those solve this equation, which means those are our possible points of inflection. So now I'm going to set up my chart to test concavity. Now I'm going from 0 to 2 pi as we saw. So we'll start at 0. The next will be pi over 6. Next possible point of inflection is 5 pi over 6. And we need to end at 2 pi. I'm going to use my unit circle to figure out what test values to use. In the first interval, I'm going to take the derivative right here at 0. Because we're going from 0 to 2 pi, I can include 0 as my test point because I know it's not a possible point of inflection. Plug that into your second derivative right here. So that's 1 minus 2 sine of 0. We know sine of 0 is 0, so this is going to equal 1. I don't care that it equals 1. I care that it equals a positive 1, which means it's concave up. So from pi over 6 to 5 pi over 6, which if you look to the unit circle is this interval, I'm going to pick this as my test point, pi over 2. The second derivative at pi over 2 would give me, go back to the derivative, 1 minus 2 times the sine of pi over 2. The sine of pi over 2 is 1. So that would be 1 minus 2, which is a negative 1, or negative, concave down. And then the last interval, you can use any number in here. I guess I'm going to use pi. A smarter choice probably would have been 2 pi, because that's the same as 0, and I wouldn't have had to do any work, but we enjoy doing trig anyhow, so let's do it. Plug in pi to the second derivative, you'll get 1 minus 2 sine of pi. Sine of pi, y is 0, so we have 1 minus 0, which is 1, which is positive. So I'm ready for my conclusions. This graph is concave up on the interval 0 to pi over 6, and then again from 5 pi over 6 to 2 pi. And it's concave down on the interval pi over 6 to 5 pi, which means both those possible points of inflection are points of inflection because the second derivative changed signs. So you have to plug them back into the original function. Now this is going to be these are going to be strange answers, but sometimes that's what you get. If you plug in pi over 6 to this function, the point will end up being pi over 6, comma, pi over 6 squared plus 2 sine of pi over 6 squared over 2, which is pi squared over 36, divided by 2, which is pi squared over 36 times 2 is 72. And then plus 2 sine of pi over 6. Sine of pi over 6 is 1/2. So that's the y coordinate. You can use a calculator and make that a decimal if you wanted to. And then do the same thing with 5 pi over 6. Plug in 5 pi over 6, you're going to get 25 pi squared over 36 over 2. So 25 pi squared over 72 plus 2 times the sine of 5 pi over 6, which is 2 times 1/2, which is 1, which just reminds me here I made a mistake. Up here I forgot to multiply by 2. This is also 1. Sine of pi over 6 was 1/2 times 2 is 1. Let me write that. If I did make any other mistakes, please let me know. So anyhow, let's just look at the graph quickly just to make sure that those points of inflection seem right. So we have points of inflection where x is 5 pi over 6 and pi over 6. So again, I use Desmos to graph this. So pi is about 3-ish, let's say. So pi over 6 is around 3 over 6, which is 1/2. So if you look at the graph at 1/2, which is right here, do you see how it goes from concave up to kind of concave down there? And then 5 pi over 6 is like 5 times 3 over 6, which is like 15 over 6, which I guess is about 3-ish, a little over 2, between 2 and 3. It goes back to concave up, and that's the case. So that's that. Thanks for watching.